ABC is a triangle. D is a point on BC such that AD is perpendicular to BC. E is a point on AC such that BE is perpendicular to AC. AD and BE intersect at O. Prove that angle DOC equals angle DEC. Where is angle DOC? Okay, here is DOC. We want to prove that it's equal to DEC. Here is angle DEC, so we want to prove that these two angles are equal. Here's one proof. Notice that angle ADC, this angle here, plus angle BEC, this angle here, sum to 180 degrees. This means that angle EOD, which is this angle here, plus angle DCE, which is this angle here, must also sum to 180 degrees. Why is that? Because we have four angles in a quadrilateral. We have a quadrilateral here, EO, or well, I could name it this way, ECDO. So the angles in a quadrilateral sum to 360 degrees. That's something you should know, because a quadrilateral just consists of two triangles. We could draw in this diagonal here, and we'd have two triangles, and the angles in each triangle sum to 180 degrees, which means that the angle in a quadrilateral four-sided figure must sum to 360 degrees, 180 plus 180. So these red angles are both 90 degrees, that's a given. So they sum to 180. So that means the remaining angles in the quadrilateral must sum to 180. Now why is this useful? Well, it's useful because we can now apply another theorem about cyclic quadrilaterals. A cyclic quadrilateral is a quadrilateral that you can draw a circle around. So the theorem that I'm applying is that if we have a quadrilateral that is a four-sided figure whose opposite angles sum to 180 degrees, then we can say that the quadrilateral is cyclic, which means we can draw a circle around it. Now this is the converse of another theorem, which says that if we have a cyclic quadrilateral that is a four-sided figure we can draw a circle around, then opposite angles sum to 180. And we can turn that around to say that if we have any quadrilateral whose opposite angles sum to 180, as they do for this particular quadrilateral ECDO, then we can say that this quadrilateral is cyclic. So this is the converse of a better known theorem. The converse is also true. So here is a rough sketch of the circle that passes through the corners of the quadrilateral. Now let's look at this arc of the circle. Now there are two angles standing on this arc. These angles are the two angles that we're interested in showing to be equal. They both stand on this arc of a circle. So now we use another theorem about angles standing on the same arc of a circle. So here's angle DOC and here's angle DEC. They both stand on the same arc of the circle ECDO, the circle through the four corners of the quadrilateral. So we just use the fact then that, well, two angles stand on the same arc, they're equal. That's all you have to say. Just state that they stand on the same arc. Well, you could indicate the arc on the diagram, or you could just call the arc DC. Just mention the circle. And that's the end of the proof.